Welcome back, everybody. Welcome back to another Stig shift. And this week's beginning of my work did not actually start at work. It started as a voluntary program to one of our local A&P colleges. That's Aircraft Maintenance College. It was a career day for the students and the alumni. It was a fantastic day. Lots of students showed up and they asked lots of great questions. Try to focus on encouraging them and getting them to their right state of mind so they can go and pass their tests and get through their college. When I got back to my regular work schedule, airplanes coming in, airplanes going out, it was actually a very uneventful weekend. Nothing really to report, nothing to really show. One thing in particular, I'll show you a difference in APU doors and some drain mass, which we'll talk about right here. But towards the middle of this video, I am going to address a few things. I'm sure that everybody now has heard about the crash in India. Lots of speculations going out, lots of theories. Now, one thing I'm going to tell you right off the bat, if you expect some kind of a guesswork from me or speculation, forget about it. You're not going to get that from me. I am not in the business of speculation or guesswork. I'm in the business of precise knowledge. I'm in the business of facts. Most importantly, I'm in the business of safety. What you are going to get from me is a detailed understanding of all the systems that people are criticizing. Everything from the rat, the flaps, the landing gear, fuel systems and battery systems. There's a lot of people out there talking and saying things without knowing how the aircraft actually functions. Now, you can listen to everybody and you can have your own opinion, but try to listen to the people that actually have real world experience on the aircraft itself. This one was a little thirsty. Give it a little oil. Walk around's good. Brakes and tires are good. Gloomy day. Sun hasn't come out yet. It's all right. Put a smile on it anyway. There you go. Oh, don't worry. I'm not going to leave it like that. I try to clean it up as much as I can, but sometimes airplanes are just dirty. They stay dirty. They get cleaned eventually. There you go. Nice and topped off. Good. A quick little topic on the Airbus 321 or the Airbus 320 family on APU doors. Here's something cool. So this is one of our brand new Neos, and there's a interesting little modification here on the tail or on APU door compartment. The Airbus 320 family is consistently evolving, especially within its APU compartment. What I want you to focus on is those three fins that are sticking out the bottom. These are considered drain masts. Now, the main point of these things is to drain any kind of excess fluid either from the APU itself or the compartment. Let's break these down. We'll go from front to back. This is the APU, and as you can see, there's plenty of lines that are connected to vital components. Some of these components have fluids that are running through them, such as fuel, oil, or sometimes even water. Water being anything that's ingested from the outside or any kind of condensation buildup. If there was any kind of leakage within these units or these components, it is good for it to drain out instead of stay in. That prevents a potential hazard or any kind of fluid buildup within the compartment or the APU. Another good reasoning for this is because it's a visual indicator for us maintenance to see if there is a problem. Here's a better representation of this drain mast and where exactly it collects its fluids from. Feel free to pause and check it out. The other two fins that you saw over there, one on the left door, one on the right, those are compartment drains. Once again, collecting any kind of fluid buildup within the compartment itself and dumping it overboard. Meaning that there's no internal leaks from the components, but there's some kind of an external leak from the components or the APU itself. Right here, I'm going to show you what the older version looks like, which only has one fin. You're gonna ask, well, what about the compartment drain? It's built into that one fin. The compartment drain is also in there. Now, the logic of the upgrade or the modification to these fins or adding more fins is to isolate certain portions of the APU. This is to better determine and isolate where the leakage is actually coming from if it is a compartment leakage. There's also another reason for this, and it's got to do with where the intake door is located on the Airbus 320 family. Auxiliary power unit on this particular aircraft is a Honeywell 131-9A. Very reliable, it's a very good APU, but it's susceptible to one thing: oil ingestion or fluid ingestion because of where the intake door is located. Now, why is ingestion of foreign fluids into the APU intake a bad thing? Well, because the APU provides pneumatic source to the aircraft. Basically, it provides air conditioning. It's taking pressure or air from the APU and sending it to the air conditioning system, the packs. If you get oil that drains or leaks within the compartment and that APU is running and that door is right there forward of that big fin, and it catches and sucks in that oil is going into the ducts. Now you have a contaminated air conditioning system. And the result of that is the SOF event. Smoke, odor, or fume. Start smelling like dirty socks in the flight deck or in the cabin. And that is not good at all because those fumes are toxic. Now, mitigating this problem has been quite a challenge. It boils down to proper maintenance and proper servicing of the APU. It used to happen quite frequently in the past, but with new service bulletins and modifications such as this, it's basically stopped happening. Now, I don't want you to panic on this at all because I want you to understand APUs are usually used only on the ground for air conditioning as well as engine startup. Flight crew and cabin crew are well trained. They know exactly what to smell for. So if a SOF event does occur, 99% of the time, it's going to be on the ground. There's another portion to this modification, and it's got to do with the inlet plenum, that big box-looking thing attached to the door. On the new modified aircraft, it's no longer attached to the door. It's permanently fixed right there. The reasoning for this is if you do not have an intake duct exposed, it's less likely that you're going to get ingestion or any kind of contamination within that area. As you can see, aircraft always improving, always upgrading, always evolving. But it doesn't even stop there. Airbus engineers are hard at work to actually relocate that intake door. They are calling it the Cobra mod, because the shape of the duct, it looks like a cobra. The location of the intake door goes from the belly to the upper right side, right next to the vertical stabilizer. You will not see this modification on the older Airbus 320 families. Why? Because it would cost millions and millions of dollars and lots of ground time for the aircraft. That's a massive modification. But the newer generation 321 XLRs and whatever comes forward, you're gonna see this. Until then, the older generation will simply have to be properly maintained, and we keep an eye on these kind of things. There you go. So next time you see this on the tail or the APU compartment, now you know why. Now that is a beautiful lineup right there, ain't it? As I mentioned earlier, the week was very uneventful, but the next aircraft we're going to be looking at is the 787, our plastic princess, and we're going to do the deep dive and start talking about the systems. In particular, the systems that are in question with regards to the crash incident. I introduced to you the GENX-1B. This is one of two option engines for the 787. You can also have a Rolls-Royce model on this, but we're going to focus on the GENX. This thing is capable of producing 80,000 pounds of thrust, depending on what type of rating it's at. This aircraft can take off and land on one engine. That's how powerful these things are. The aircraft, as well as the engine, is heavily based within electricity. As most of you know, it's FADEC controlled and it's a fly-by-wire system. No cables, no RAWs, no nothing. It's all computers. Each engine has two VFSGs, variable frequency starter generators. These things are used not only to start the engine, but also to provide power to the aircraft. Both generators are attached to the engine accessory gearbox. That's what it looks like when one of them is removed. I'm going to show you to you on the bench. Each generator is capable of producing 235 VAC. They are oil-cooled and brushless generators. Regardless of what power setting the engine is providing, thrust-wise, these generators are always running at a constant speed. They have a built-in CSD, constant speed drive. They also have a permanent magnet generator that sends power to the GCU. the generator control units. This is not to be confused with the PMA, the permanent magnet alternator. Don't worry, we're going to get to that too. But the topic of discussion right now is an airworthiness directive that was put out by the FAA and Boeing. By the way, this is public knowledge. You can go look this up yourself. So what they figured out is that if the aircraft has continuous power beyond 248 days, it can lose all AC power. This is due to the GCUs going into a fail-safe mode. This was caused by software. The fix for this? Turn the airplane off for a while and then turn it back on. But one thing people failed to realize, or I should say neglected to do the proper research, this wasn't the only AD for power cycling. They had many more. Here's another example of it. A power cycle every 51 days for the CCS, the Common Core System. By the way, guys, I just want to let you know, this is going to get very complicated very quickly. I'm just trying to let you know how it works in a very simplified manner. You want another example? Here we go. Another AD. Another power cycle. This time every 21 days. This one focusing on the flight control modules, the FCMs. Now, given the status or the maintenance program that the 787 is under, most likely one of these three procedures or ADs was performed. Okay, let's go back to the engine again, and I said I was going to talk about the permanent magnet alternator. It's this little thing right here. Here's a better picture of it. Now, remember when I told you that these modern engines nowadays are all fly-by-wire? They are controlled by a dual-channel computer called the EEC, the Electronic Engine Control. Right there, that big gray thing. The EEC will get its power from that alternator as long as the engine gets to 8% N2. And let's say if that alternator does fail, the aircraft itself can still provide 115 AC voltage to the EEC. Let's reverse this. Let's actually put the failure on the airplane side. That little permanent magnet alternator is directly connected to the gearbox. So as long as the gearbox is turning, as long as the engine is turning, that alternator is going to keep providing power to the EEC. So the scenario is complete full power loss on the aircraft side. Now, multiple things are going to be occurring. The wrap might drop. There's going to be load shedding within the electrical systems within the aircraft. You can even have your fuel pumps not working. We'll get to that one, don't worry. Point here, as long as that engine is turning, that engine control unit, the EEC, will still function, will still regulate this engine to keep it running. That's how much redundancy that's being shoved into this. The engineers made sure that whatever happens, those engines keep on running. Now, this conversation is going to take us to fuel and fuel starvation of what other claims of why they lost propulsion. Some are claiming that the fuel pumps stopped working. Some are claiming contaminated fuel. I think I even heard somebody say vapor lock. Fuel contamination is a possibility. There was an incident not too long ago. A Jetstar 787 did have dual engine failure at 16,000 feet due to biocide treatment within their fuel tank. Managed to relight those engines and land safely though. It's a possibility, but a very low probability. Let's focus on the fuel pumps themselves. There's 6 in total. 2 per wing and 2 in the center. This is providing positive flow to the engines. Now, there's also a fuel pump on the engine as well. But here's the redundancy, which most people got wrong. Even if those fuel pumps within the wings are not working, it will still feed fuel to that engine via gravity and a suction system. As long as that engine is turning, it's going to be pulling the fuel. Only way you're going to stop that fuel from flowing if you pull the T-handle, which is the fire handle, or shut off manually the switches for fuel, which is the fuel cutout switch. At that point, your spar valve is closing off, and that's when you got real fuel starvation. Guess what? It wouldn't even matter if the filters were clogged. The aircraft is designed to bypass the filter and still feed fuel to the engine via these nozzles. By the way, this isn't just a 787 feature. All airplanes are like this. The only time I've seen vapor lock is on general aviation aircraft, either a carbureted source or even a direct port injection. I have never seen it on a massive jet like this or a high bypass turbofan. There's just way too much PSI being pushed through the fuel manifold and through the nozzles. I do want to revisit contamination once again because I want to make it clear, and as well as some maintenance procedures. There's a few things that maintenance does to prevent contamination within the fuel. Usually on overnight stays, we sump the tanks to make sure there's no water in there. Also, the 787 has a fuel and water scavenge system. There are 2 water scavenge jet pumps on each of the main tanks. The jet pump pulls fuel from the bottom of the tank and sends this fuel to the boost pump inlet. It goes through the inlet and mixes with adjacent fuel before it is pulled through a screen by the boost pump itself. This prevents from too much water at the bottom of the fuel tank or any contaminants. The side effects of what you're going to see of real contamination or the fuel that's bad, you're going to see sputtering of the engine. You're going to see a compressor stall, bad RPM, bad EGT readings. And if that happens, you're going to see a big black soot out the back of that engine, smoke or flame. He saw none of that within that crash. Okay, we are done with fuel. Let's move to the landing gear. Most notable thing within the crash, the landing gear were down. A lot of people were pointing to the tilt angle of the truck. Lots of questions on this one. First of all, let me mention that there are no hydraulic sequence valves used in the landing gear operation of the 787. Proximity sensors are the ones that take over and act as a sequencing valve to detect gear position. This is what we really want to talk about right here, isn't it? The truck stow actuator, better known as the tilt actuator. Primary purpose of tilting the gear is just simply to make sure it fits within the wheel well. Now, your primary question is going to be what actually activates this little system. After thoroughly reading through the manuals and consulting with my colleagues as well as some Boeing professionals, we all understood it's the gear handle that initiates that sequence. Even read straight from the book so you got a better understanding of it. Main landing gear truck stow proximity sensors gives an output for these conditions: main landing gear truck stowed and main landing gear truck not stowed. Truck stowed proximity sensors are part of a proximity sensor truck positioning assembly. There's one on the left, there's one on the right. You know, redundancy. The retraction sequence of the landing gear is controlled by the proximity sensors, but the signal comes from the handle. The handle is the thing that sends the electrical signal to allow hydraulic pressure to flow through these things. If the gear is not shown in a position of 12 degrees nose down, this is the tilt portion of it, it will not retract or extend. And here's more interesting information. Each proximity sensor truck position assembly also holds a truck tilt proximity sensor for air to ground indication. So it's doing two things right here. The aircraft wants to see weight off of wheels, and it also wants to see gear handle up to initiate the sequence. Now remember, this is a 787-8. Dash 9s and Dash 10s work a bit differently. They have a whole different type of sequencing, especially when it comes down to the gear doors. Now, why am I talking about all this? Because the question in hand is, did the pilots go to retract on the gear? From how the manual reads and how the description is of the system, they pulled up on that gear handle, they initiated the sequence. Show you a nice example here, another 787 on a normal takeoff. Watch and look carefully on the tilt. I'm going to slow it down for you and I'm going to zoom in. So here we go. Pay attention to the tilt. V1 rotate, positive rate, gear up. Gear door down and tilt almost happen at the same time, milliseconds apart. That leads me to believe that gear handle has to be put up position for this sequence to occur. Feel free to rewind this and watch it and give me your opinion. If I missed anything over here, feel free to put it down in the comments and correct me. That explains the gears. Let's go into the flight deck. The initial notion or hypothesis that a captain brought up is that the first officer reached for the flap handle instead of the gear handle. And everybody was asking how far away are they apart from each other? Actually, very far away from each other. Let's focus on the flap handle itself first. Now, normal configuration for takeoff on a 787 is usually between 5 to 15 degrees. For somebody to inadvertently take a flap handle to go from either 15 to 5 and beyond 1 degree of flap deployment, they have to pass through a gate. A gate is a detent. Have to go down and go back up to release it from there and to go back to full up flaps. Somebody on our internet decided to blame the pilots for inadvertently grabbing the flap handle and going full flaps up instead of going gear up. And you know exactly who I'm talking about. Not only do you have the gates within the flap system to prevent you from going to certain detents, you also have shapes and sizes of the flap handle and the gear handle. Everything within the flight deck is not made to be aesthetically pleasing. It's all about functionality. Every single one of those control handles is shaped a very different and particular way. The reasoning behind this concept is if there was smoke or low visibility within the flight deck, the pilot can reach down and grab hold of their control, whether it be the flap handle, the spoilers, the landing gear, the throttle controls. They will know what they are holding just by the shape and size of it. Hopefully that clears this up, and in combination with what we talked about earlier about the landing gear tilt and the sequencing, yes, those gears were set to up. In whatever images that I gathered from online, it looks like they confirmed that the flaps were still deployed. Once again, ladies and gentlemen, I am trying to go on factual data. I'm not guessing, I'm not speculating, I'm not assuming. With all that being said, now let's transition to another topic, which is the flaps themselves. We're going to talk about another little feature that the 787 has. The topic of conversation now transitions into the auto gap protection or the auto gap function. This is a very specific function in regard to the leading edge slats and how they behave at certain airspeeds. Now, the whole concept with flight controls falls under 3 basic parameters within the 787. primary, secondary, and alternate. These are your redundancy factors. What we are wanting to focus on is the slat auto gap function. The primary purpose of the function itself is to auto deploy slats to improve lift and prevent stall. This is accomplished by automatically extending the slats from the middle position to full extend position before a stall actually occurs. Now, this is interesting. The auto gap function is inhibited when the airspeed is above 225 knots. Just on a side note, this system is a purely automated system. It's not even telling the pilots what it's doing. It will just do it. It will collect data from the AOA's angles of attack and cross-reference it and making sure the aircraft is in correct orientation. If the aircraft senses that it is not in proper configuration on a takeoff sequence, whether it be AOA's or speed, it will fully deploy its slats, even if the flaps are up. And here's the real interesting part about this. The auto gap takes priority over landing gear retraction. So even if somebody mistakenly went to flaps up instead of gear up, let's say the flaps will retract, but those slats will fully extend. I do apologize. I could not get any kind of footage of the slats themselves, how they deploy. This is the best I can do at the moment. The flight control operational check. Believe it or not, this check takes an hour to do. Another interesting side note, sometimes pilots will take off and they will intentionally leave the gear down. This is because when they're taxiing around before takeoff, sometimes those brakes and tires get very hot. So they'll just leave the gear down, cool it off. Once they get to a certain altitude or when the brakes cool off, they will retract. Throughout that period, they are able to retract flaps, but the slats will stay down. At that point, pilots will have sufficient altitude, sufficient airspeed, and they will just simply clean up the airplane, as in full flaps up, gear up. That was the auto gap. There's also a pre-gap. Now, secondary mode and alternate mode functions are completely different because now you're going into a bit of a rudimentary logic within this aircraft. Pilots have to take over at this point. This function is called a pre-gap, and it operates when the airspeed is below 225 knots and the flap lever is not in the up position. It's almost doing the same thing as the auto gap, but this feature is doing it because there's some kind of a failure. There's one more function here called load relief. This is specific to the flaps themselves. Will automatically retract the flaps in case of excessive air loads. Basically, the airplane is saying, you're going too fast with your flaps down. I'm going to retract. So a quick overview. In primary mode, everything is functioning normally. Pre-gap and the load relief only happens in alternate mode. At that point, the pilot has to do pilot stuff. Aviate, navigate, communicate. In my personal opinion, those pilots did the best they can. They even let out one last ATC call. According to news sources, thrust not achieved, falling, mayday, mayday, mayday. Even they knew they were doomed, and they still let out a transmission to help us put the puzzle together. I pray for all the souls that perished within that crash. I hope they get to the bottom of this soon. We got one more topic, ladies and gentlemen, and that's going to be talking about the rat, so bear with me. We are almost done with this. We are back into the flight deck of the 787, and let me show you the push button that manually extends the rat. It is on the overhead, on the hydraulic panel, right above the hydraulic pump switches. The ram air turbine, better known as the rat. Now, I have made many videos on this, not only for the Airbus family as well as the Boeing family. But the Boeing 787 is very specific when the rat deployment happens automatically. You saw me point at was the switch for manual deployment. Now, I'm simply going to tell you that flight time was less than a minute. I highly doubt those pilots had enough time to reach up there and deploy a rat manually, let alone get through the checklist to actually deploy it. It's pretty much confirmed at this point that the rat was deployed on that aircraft. Audio is already there. We can all hear it. Go check out Mr. Juan Brown's channel. He does a very good understanding of this. I'm sure he's going to have a follow-up video which he will explain further. The question on everybody's mind right now, what actually causes a rat automatic deployment? And this is where confusion sets in for people who don't actually work on that airplane. It's not just 3 things that deploy that rat automatically. There's a lot more things that deploy that thing. I'm going to try to make this as simple as possible and list the parameters of when the rat automatically deploys. Loss of all engines. Both engines are at less than minimum idle RPM, revolutions per minute. Loss of all hydraulic power. That means left, right, and center systems detect low pressure. Loss of all electrical power. Loss of the BPCU, bus power control units, which detects the lost power of the C1 and C2 TRU, the transformer rectifier units. On approach, loss of all 4 EMP, electric motor pumps, hydraulic pressure, and loss of either the left or the right flight control ACE, actuator control electronics. And last, rotor burst on the takeoff that causes the loss of both PECs, power electronics cooling systems, primary cooling loops. As you can see, a lot more parameters than your other traditional aircraft. Once again, the fail-safe and the redundancy portion is still there. It still has to go through lots of redundancy failures for it to reach this point. And I've got the question of, do we do rat checks? Yes, we do them all the time. These are scheduled checks. So I'm doing this a bit backwards. The functionality of the rat itself, why is it needed? It's there to provide minimal electricity and minimal hydraulic power in case of all those failures that I just talked about. And this is how the rat actually looks like on the 787. It's not as big as you think. It's actually small comparison to the big aircraft. That's why it's so hard to capture it on the video of the crash. But I assure you, it was there. Not only can you see it, if you clarify the picture, you can hear it. Matter of fact, you're going to hear it here as well, because we're going to do a rat check right here. And by the way, the cage is simply there so we don't accidentally walk into it while that thing is spinning. That's it. When we do this test, we are making sure that we're getting proper pressure output and making sure the electrical portion as well is working. Okay, without further ado, I'll turn the audio back on and you can hear this thing. That is it, ladies and gentlemen. This is all the information and data that I can collect for you. I hope it makes you better understand the aircraft. At the end of the day, it's going to be the responsibility of the investigators to figure out why this happened. Just like I said in the beginning, I'm here simply to tell you how it works, not why it happened. The rest of this video is going to be brake riding, so if you enjoy that, stick around. If not, thank you all so much for watching. I appreciate every single one of you, and I'll see you on the next one. Stig, signing out. Later.
Except 323 miles to tower 120, but I see 500 tower CF 623. Ground Taylor 4895, checkpoint Q to the box. Taylor 4895, LA ground Bravo, Charlie 5, Charlie to the box. Bravo, Charlie 5, Charlie box, 325. United 1229 miles to 120, 105. 1229 miles to tower, okay, was 59, 2037, running ready over there. One. Skywise 5920, LA ground Bravo, Charlie 6, Bravo, Charlie 6, Gus 920. American 2037, LA ground Telly from Charlie runway 25, right information, hotel. East of Charlie from 25, right, we have hotel, American 2037. Anyone else waiting? American 155 heavy, come to Charlie transport, Charlie 17. American 155 heavy, LA ground proceed via Charlie to Charlie 17. Charlie to Charlie 17, American 155 heavy. Up to 8842, ground taxi straight ahead on Quebec, left turn on Charlie, hold short of Yankee. Anyway, Charlie, short of Yankee, Delta 80. Up to 8842, contact ground point 656 here. The ground. The coach at 579 at signature with the call for the taxi. Exit at 579 on the ground, runway 25 block, taxi Alpha, hold short Foxtrot, information hotel. Alpha, short Foxtrot, for 25 block, Booking Hotel, coach at 579. American 155 heavy at Papa gives way to a Turkish 777. Give way to a Turkish 777 at Papa, American 155 heavy. United 77 LA ground, push back, tail to the east onto Charlie. Turkish Niner heavy LA ground, taxi Bravo, Lima to the city ramp.
Taxi Bravo, Lima to the city ramp, Turkish Niner heavy.
LA ground, United 1754, checkpoint 2. United 1754 LA ground, give way to a heavy American tail left to right on Charlie, then Bravo to Charlie 7 ramp.
Alright, Bravo Charlie 7 ramp after the American heavy, United 1754.
Make pitch at 579, monitor 120.5, be ready for both sides, tower may assign your runway 25 right, have a good one.
Alright, 295, we'll be ready, catch it at 579.
Clear, 2073 crossing 25 right at Juliet, climb 56 Bravo. Clear 2073 on the ground, Bravo Charlie 8 to the ramp. Bravo Charlie 8 to the ramp, clear 2073. Turkish Niner heavy, contact ramp 131.075.
Ramp 131.075, I'm holding it yesterday.
United 576 LA ground, Bravo Charlie 6 to the ramp. Taxi ground, United 576, checkpoint 2, going to 70 Bravo. United 576 LA ground, taxi via Bravo short Charlie 6. Bravo short Charlie 6, United 576. United 77 advise ready.
We are ready, United 77.
United 77 proceed via Charlie 7 Bravo Charlie 5.
Ready, Bravo Charlie 5, United 77.
Turkish Niner heavy, turn left on Lima.
And that's it. I will wait for it to turn off. It's going to take forever and a day. All right. We'll wait till this thing shut down, and we got a couple more moves. Let's go. And we go back to a bus. Cabin's already clear. Everything's already set up. Ready for a nice pleasant ride. Let's go.
United 2238, continue straight ahead, Bravo, and then it's probably somewhere to the left out.
Alright, just grab it, Charlie 7, and yeah, we're cleared in after one out, United 2238.
South 3394, Los Angeles ground, runway 25 right, taxi via left on Bravo in front of the United.
25 right, via left on Bravo, go press, Air 3394.
Air France 25 Golf Heavy, taxi left on Charlie, Lima, hold short of Kilo 1.
That's it, Charlie, Lima, Kilo 1, I have buses, cyclist.
American 968, Los Angeles ground, Toronto, Charlie, Charlie 10 to the ramp. Last 493, monitor tower 2095.
495, yeah, 1
American 968, turn right on Charlie, Charlie 10 to the ramp.
Right on Charlie, Charlie 10 to the ramp, American 968.
Ground United 609 on Charlie for 83.
609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for 83. 609 is on Charlie for
Yeah, 609 Los Angeles ground, Bravo, Charlie 6 to the ramp.
Bravo, Charlie 6 to the ramp,
Client 64, approaching Charlie. Park line 64, Los Angeles ground, taxi via Bravo, Charlie 8 to the ramp.
Bravo, Charlie 8 to the ramp, line 64.
LA ground, this is American 46 Bravo at the top of Charlie 9, there's November 1.
American 46 Bravo, Los Angeles ground, going to be a moment, hold short of Bravo.
No problem, holding short of Bravo, American 46 Bravo.
Air France 25 Golf Heavy, contact city ramp 131.07.
3107 Air France, 25 Golf Heavy.
Tower 3394, monitor tower 2095. United 2297, can you Bravo Charlie 6 to ramp?
Bravo, Charlie 6 to the ramp, United 2297. Ground Frontier Flight 4964, not kilo, gonna help short. Charlie, taxi, information kilo.
Frontier Flight 4964, Los Angeles ground, behind a Hawaiian Airbus from the right, then runway 25 right, taxi to Bravo.
Alright, hold short, wait for the Hawaiian to pass, and 25 right for your Bravo, Frontier Flight 4964. Ground Jet Blue 824, 859, push.
Blue 24 Los Angeles ground, runway 25 right, push on Charlie tail west.
25 right, Charlie tail west, we have kilo, Jet Blue 824.
Turkish 10 heavy, continue forward, hold short Charlie 10.
Hold short, Charlie 10, Turkish 10 heavy.
46 Bravo, turn right on Bravo, Charlie 10, Charlie, November.
Bravo, Charlie 10, Charlie, November, American 46 Bravo. Ground, good evening, Philippine 102 Heavy on Papa.
Finnair 2 heavy, pass behind American Eagle Embraer at Gulf.
Hi there, Embraer from Gulf.
Philippine 102 heavy, Los Angeles ground, taxi via Bravo, hold short of Lima.
Taxi Bravo, hold short Lima, Philippine 102 Heavy.
Turkish 10 heavy behind the American tug ahead, continue via Bravo.
Behind the American Heavy, continue on Bravo, Turkish 10. And ground Skyler 6506 is off 25 rated Golf for D52 Fox.
Ground 6506, Los Angeles ground, turn right on Bravo, Charlie 4 to the box.
Right Bravo, Charlie 4 to the box, Skyler 6506.
Finnair 2 heavy, monitor tower 12095.
Monitor 12095, Phoenix 2 heavy. American 205 taxi on Juliet.
American 205 is going to be a moment. Wait for a Frontier, it'll be the third aircraft you see, and follow them, runway 25 right, taxi via Charlie 9er Bravo.
Charlie 9er Bravo behind the third aircraft at Frontier, American 205.
Point 64, there's one in the alley, continue to Charlie 7, back on to Charlie, and then wait for one out at Charlie 8.
Charlie 7, back to Charlie 1. Charlie 64. Delta 26 Alpha, checkpoint 3 to Wama.
Delta 26 Alpha, Los Angeles ground, proceed to Wama.
Proceed to Wama, Delta 26 Alpha. Ground Turkish 10 Heavy, should we expect any delay if we request intersection Bravo 1?
Turkish 10 heavy, plan for the full length, there should be minimal delay. Monitor tower 120.905.
Monitor tower 120.905, Turkish 10 Heavy, thank you.
Philippine 102 heavy, taxi via Lima to the city ramp. Contact the ramp 131.07.
Taxi Lima to the city ramp and city ramp 13175, Philippine 102 heavy, delay. Ground 2037, Charlie 8 with Juliet taxi.
Right, 2037 Los Angeles ground for sequence. Follow the American off your right from runway 25 right, taxi to Bravo.
25 right via Bravo, follow the American on our right, 2037. Ground Skyline 4928, checkpoint 2.
Skyline 4928 Los Angeles ground, taxi to Bravo, Charlie 5 to the box.
Bravo, Charlie 5 box, Skyline 4928.
Ferguson Heavy monitor tower 120.95. Frontier flight 4964, monitor tower 12095.
And outside, Frontier 496. Grand Template 24 tag.
Okay, all done with that. I already got everything turned off. That's it. I'm not sure if we have another move, but we'll see. Gotta get back to the office first. And everybody always wonders, how do I get back to the office? Somebody comes and picks me up with a vehicle. That's how. But yeah. Oh, there it is. There's my ride. Okay. Wait for the batteries, and there we go.